So because we went over that homework, this should be maybe more straightforward. Now, here's what we're trying to do. We're trying to solve this equation right here. We want a solution. What is a solution? A value, an unknown value that makes the equation true. What's our unknown? X. So we're looking for an X that makes this true, right? Now, to find the solution, we will talk about how to do this algebraically, but first we're going to do it graphically. Because we can do that. With a graph, we can basically say, okay, this and this are equal. Well, let me just graph this, and wherever they cross, that must be where they have the same value, right? They must be where it's the same. So what you do, and this is your strategy, if you want to do this by graphing, is you take this part and you make it a y equals. You say y equals square root of x plus 6 minus 2. And then you take this part and you make it another one. You say y equals square root of x minus 2. And you graph each of those. After you graph each of those, you'll see where they cross, and it'll reveal the value to you. Okay? So that was your warm-up. I would love to give you more time to do it, but we are still in the warm-up and we have 20 minutes. So plus 6, we'll do it together. Plus 6 underneath tells me to go to the right. Left 6. And then minus 2 tells me to go down 2. Any stretches, flips, shrinks, bits, bops? No. Okay. So we're going to go over 1, up, over 4, up, over 9, up, over 16. Look at that. We got it. There you go. That's our first graph. Our second one's even easier. All it is a negative 2 underneath, x minus 2. That tells me to go, minus 2 underneath tells me to go, right 2. And still no stretches, no flips, no shrinks. Okay, so over 1, up 1, over 4, up 2, and that's good enough. We've already crossed this thing. Okay, where does this thing cross?
1 and 3.
At 3, 1. Now, great, that's a good point. But what were we looking for? An x value that makes it true. Which one of those is an x? 3. So it turns out we only needed that part. And our answer is x equals 3 makes this true. That's our solution. And how could we be sure? Plug it in, right? And in the interest of time, we're going to do this mentally. 3 plus 6 is, square root of 9 is, 3 minus 2 is, square root of 3 minus 2. 3 minus 2 is, square root of 1 is, so 1 equals 1. This works, right? This gets you the value that makes this is true. Now, you don't have to do that mentally. You can plug it in and prove it to yourself with written work, right? Okay, so this strategy will get you that value that you're looking for, okay? Now, what else was I going to say? Wait, this one's even easier than the last one, but actually it's not. Like, it's easier in that the actual math is simpler, but this one breaks brains. I don't know why. But it's nothing personal because it's very consistent across my classes. Because you're like, okay, I know what to do with this part. Because we said we make the left side an equation, right? So this becomes y equals 2 square root of x plus 1. But what do I do with the 4? Just y equals 4, right? It's just y equals 4. Just because it's a number doesn't mean you can't make y equals to it, right? And that's a part that gets confusing for people. But you can make y equals a number, okay? And in fact, it's a really easy thing to graph. Does anybody remember how to graph y equals a number?
Just a
straight line, right? Y equals 4, I'll tell you where y equals 4. Right here, forever, right? So essentially, when we graph this red one, all we're checking is when do we cross that line, right? So now you want to graph the red one, okay? I'll give you a second. Go ahead. Try to graph that red one. So, okay, so this one does have a stretch. It's got this 2 out front, right? We'll deal with that after we find our new starting point. If you're plus 1 on the inside, where are you going? left 1. And then I'm not going to go down because it's not flipped. I'm going to go over 1, up 2. Good. I'm going to go over 4, up 4. Sweet. I'm right on that line. Okay, so what's the value that makes this true? 3, right? Because we have the point 3, 4. So 3 is our x that makes this true. Again, we can test that. 3 plus 1 is? 4. Square root of 4 is? 2 times 2 is?
4.
See, it works, right? All right, so your teacher gives you these things. Like, he's not going to give you them if they don't work, right? You're always going to find solutions, right? I would never betray you in that way, right?
No.
All right, so try this problem.
You would definitely betray.
Okay. I would never. I would never do that. All right, so this will be y equals the square root of x plus 3. That shouldn't be underneath. Plus 3. And this will be just y equals negative 2, which now we remember is just straight lines across at negative 2. Whoa, what happened? Okay, and then we'll just find out where this crosses. Perfect. What does plus 3 on the outside do?
Up 3.
Up 3, okay, from 0, 0, right? And then no flips, no stretches, no shrinks?
Nope.
So over 1,
Do normal.
up 1, over 4, up 2. Oh boy, oh boy.
You lied.
So did I lie to you? Yes. That's not really true. I don't know about that. I said this would work for finding solutions that make it true. Right? That's what I said.
Imaginary.
Hold on. Not quite imaginary. What do we find?
Oh, wait.
Hold that thought. What do we find?
X does not equal
0.
There's no cross, so that means there's no what?
solution.
No solution, which means there's nothing that
Solve
makes it.
true.
It's the reason I hammer that definition. Nothing makes it true. Why on earth would this be the result? Nothing makes this true from that equation. That's my question for you. This is a question of the 2 periods I had today. One's gotten it, one hasn't. So what do we think? Why did this happen? Why did we not find a solution? Why does it make complete sense? Why, when I gave you this problem, could you have been like, I don't think so, teach. Haven't even picked up my pencil. I know this isn't going to work. Because why?
Because life is a lie and not everything has an answer.
Negative.
Sorry, I heard a lot. Go ahead. Daniel.
One is positive and one is negative. Like one side is positive, it's not going down. And one
Okay.
is negative.
Give me more.
There's no reflection, so you couldn't have reached.
Okay, that's kind of why the mechanics didn't work. Talk to me at a higher level.
Higher level.
Are you talking philosophical? Because I have an answer for that.
Not that high. All right, this is what I want you to do.
What?
Look at this equation.
Oh,
Tell me why that could never happen. Pretend you didn't have a graph. Why?
2.
Positives can't make a negative.
Well, how do you know that's positive?
Because it doesn't have a negative.
A negative can't be a square root.
Because anytime you've ever square rooted in your life, you got a positive. And then we took that positive and we added 3 to it. And we made it even more positive.
Yeah.
And then we said, hey, that's probably equal to negative 2.
That's not how that works.
That's not possible, right? So this was flawed from the beginning and was never going to happen, and the graph proves it. Okay? So we can recognize, we have to, in this unit, in this section, we have to stay self-aware, meaning we get into the steps and we get into the zone. I want you to think about the situation every time. Like, is this possible? I don't know. Because things can happen, and that's not even the only thing. All right, we're going to do those algebraically, the same 2 equations, okay? Now, the good news is we already know how to do this, right? So we won't spend a ton of time on this. Because square rooting something is the same as raising it to the what? No, that's squaring it. Square rooting something is the same as raising it to the 1/2. So this is really 2 times x plus 1 to the 1/2 equals 4. And you don't have to do it this way, but we're very familiar with this. We just did this, right? Now we isolate the power, yeah, the thing being raised. So I need to divide by 2, divide by 2. I get x plus 1 to the 1/2 equals 2. How do I get rid of a 1/2? Square it. Same way you get rid of a square root, by the way. I get x plus 1 equals 4, and then I subtract 1, and I get x equals 3. How do I know that's true?
From the graph.
Well, yeah, we just did it. This is the same equation. Also, I could plug it in. Okay, now, we know this doesn't work, so we shouldn't get an answer here, right?
No, that's wrong.
I just got tricks upon tricks. You know not to trust me at this point. It's kind of a bummer. All right, here we go. What do I do to get this thing by itself? Okay, this is what I mean by saying self-aware. I want alarm bells going off in your head at this point. What do you see on the page?
An answer.
A square root that equals a negative. So that was never going to happen. But we're gonna humor our teacher, and we're going to keep going. Oh boy. So then I square this side, and I square this side. I know this isn't going to work, but that's okay. We're going to do it. And then square root squared is what? It's just x. And then what's negative 5 times negative 5? Oh boy. Oh boy.
Oh my god.
Why did we get an answer?
Because 2 negatives.
So I'm going to tell you a very quick story. What I'm about to tell you, some of you might know a student that I won't name, but he's very, very opinionated. Last year when I got to this point and I explained why we got this answer, he just yelled, "No." And I was like, "What?" And he's like, "I do not accept this." I was like, I don't know what you mean. He's like, I just don't accept it. I will not. That's not fair. It's just not fair. Because this is called an extraneous solution. It is a phenomenon that happens when you do nothing wrong and you get an answer that makes no sense. And I agree it's not very fair. The good news is there are clues that it will happen. What was the clue that it was going to happen? This thing was flawed from the get-go, right?
Because it's a positive.
This was never going to happen. So if you got a solution from this, it should make no sense to you that you did, right? Also, it happens a lot when you square things. You fundamentally change an equation when you square it. You add a layer to it, and sometimes that layer gives a false solution. I'll show you what I mean, okay? Let's look at this next example. Okay, so here we go. To solve this, right, we would square both sides, okay? But before we do that, what power is x being raised to right now? And we remember that when we had like quadratics, we would get 2 solutions. When we had cubics, sometimes we get 3 solutions. When we had the first, we would just get 1 solution, right? So if I square this, right, I end up with x plus 1 times x plus 1. On this side, I have 7x plus 15, right? This I would FOIL or box. I'd get x squared plus 2x plus 1 equals 7x plus 15. Okay, when we have this type of situation, what type of situation is it? It's a quadratic. We're going to move this over, get it equal to 0. We're going to solve it. How many solutions are we going to get? Well, 2. Oh, 2. And does that make any sense for where we started? No, we fundamentally changed this equation by messing with it, and there are consequences to that. Sometimes that consequence is an extraneous solution, okay? So, minus 7x, minus 15, minus 7x, minus 15. We get x squared minus 5x minus 14 equals 0. How do I solve this? Don't say the quadratic formula.
You move the 14.
No. Magic X. It's like y'all just love the quadratic formula so much. Like, you need to get like t-shirts. Like, I love the quadratic formula. Maybe I'll get them for you. Because you use it way too much. It's so much more work than -7 and 2. Like, it's so much easier. X minus 7, x plus 2. You'd rather go x equals -b plus or minus square root b squared minus 4ac all over 2a. I mean, I'm happy that you like math. Okay, so here are our two solutions. Boom, boom. What's the problem? We shouldn't have got two solutions to the original. It was just x to the 1. That gets you one solution. So that's your clue that one of these might be extraneous. How do you know one of these is extraneous? How could you find out? Solutions are things that make something
True.
Check if they make it true, right? So 7 plus 1 should equal the square root of 7 times 7 plus 15. 8 equals the square root of 64. 8 equals 8. Okay, you seem okay. Your friend might not be cool. All right. -2 plus 1 equals the square root of 7 times -2 plus 15.
You can't have a negative.
-1 equals, pause, done. Don't need to do anything else. If at this point you get this far and you write underneath it, I'm done. You can't square root and have a negative. I know this is wrong. That would be enough for me. That would tell me more about what you know than if you finish this problem. No, you have to explain why. So that is not a good solution. It didn't make it true. Does everyone understand why?
Yeah.
You cannot square root and get a negative. It doesn't matter what this is, okay? Now, the only other two problems here.
So we did get one answer.
Yeah, we did. One of them was false.
Oh my God.
Okay, yeah, see, it works. You have to trust me.
Okay.
All right, hold on, real quick, and I'll hand out your homework. These are the same concept, right? But now you have your rational exponents, so it's a little trickier, a little bit more level. This one, if you're going to do these at your home for fun, this one does not have extraneous. This one does.
Oh, thank you.
Okay, so this is just a review of graphing radicals. Do you remember all the way back, second unit of the year, maybe? First semester, we graphed parent functions, right? That's what this was about. And it's just one of them. It's just the square root function, right? And it's just about like, okay, do I know my parent? And then can I move things around? And I feel like a lot of people were just like, didn't even, like in my classes today, didn't even connect those dots. Like, oh, that's what this is? Is that parent function thing? So maybe after going over this, you'll be like, okay, now I remember this. So that's okay. It was a long time ago. All right, so in each of these situations, there's the parent function and then things that happen to it. Does it move up? Does it move down? Does it go left? Does it go right? Does it flip? Does it stretch, right? All those things. And in some of them, like one thing happens. In some of them, a couple things happen, right? Like in this one, two things happen. In this one, one thing happens, right? In this one, four things happen. Four whole things. And that's your max, by the way. 4 is the max that you can have in terms of things happening. So rather than jump around and try some 1s or 2s, let's dive into a 4. Let's do the one with all the things, and that way you can see everything in one problem. We'll knock it out, and then we'll be solid on this concept again, okay? So go to number 4, please. All right, so for number 4, again, your principle, your concept here is there is this parent function. In this case, the parent function is what? Square root of x, right? And this function is the same all the time. And if you know that, you have to know this function to do that one. But if you do know this function, you can do that one by just changing this one a little bit. Now, this function is the square root of x, right? So there's a couple ways to remember how to graph the square root of x. You can just remember the pattern, which is kind of where we focused in the second unit of the year because we weren't quite ready for the concept, but I'll talk about both today. All right? The pattern was, okay, we know we always start at 0, 0. And then we go over 1 up 1. And then we go over 4 up 2. And then if we had to, we would go over 9 up 3, right? Now, that is the pattern. That's memorizing a trick, some steps. But let's go concept. Why is it 0, 0, 1, 1, 4, 2, 9, 3?
Because those are square roots.
Because those are square roots, right? Now that we know our squares and we're used to radicals, right? We can think about that, right? What's the square root of 1? 1. What's the square root of 4? 2. What's the square root of 9? 3, right? So you actually don't need the pattern anymore. You still want it because it helps, especially if you move stuff around. But at least now you understand the pattern, right? If I went over 16, how much would I go up? 4. Exactly, right? So now full understanding, right? It's going to help you remember that pattern the next time. Okay, so that's the parent function. You could always add it to your graph if it helps, right? You don't have to if you just remember it. Now, we ask ourselves, well, what changed from that over here? And remember what I suggested way back in the day was to make a list. And I'm going to tell you that there are 4 things, right? So I would number 1 through 4. I'd say, hey, I know I got 4 things. Let me just list them out before I try to graph them. So then I know I can cover all of them. I can check all of them, right? And then I like highlighters because I have highlighters. If you don't have 4 different color highlighters, that's very normal and that's okay. So circle, do whatever you need to do, underline, arrows, whatever. But I'm going to use some highlighters, right? There we go. There's one thing. There's another. There's another. And that's just one thing. That negative is one thing because this 4 is a different thing, right? There are your 4 things, right? So if those are our 4 things, we need to know what each one does. And each one does a different thing, okay? I feel like I said the word thing about 10 times. Okay, so we're going to start with the stuff on the right because that changes our starting point, and we kind of need to know our new starting point before we can start. Now, anybody remember what underneath makes you move? Right or left? And annoyingly, the negative makes you go right to a positive direction. That's just this weird thing that happens. We know why it happens, but it's still kind of counterintuitive. So we're going right how many? 3. But the good news is on the outside where you go where? Up or down, it's not annoying. It says +5, so you know you can go up 5. Okay. Now I personally would keep going writing all the things, but I'm going to pause us here because this actually is a good breaking point for you mentally because this stuff changes where you what? Where you begin, right? So this changes your start. And then this stuff will change where you go, right? So 2 of them change your start, and 2 of them change your movement. Okay? All right, now let's talk about the other ones. The other 2 things are always on the front. So anything in the front changes your movement. Anything in the back or in the inside changes where you start. So I got this negative. What does that do? Flips everything down, right? Reflect is the word. Flips down. Y'all remember this well, actually. And then the 4 makes me stretch by 4, right? If it was a fraction, I would shrink. Stretch 4. Okay, so we have we know everything is going to happen, right? And by the way, this is the answer key, so that's why there's already a red graph on there, right? So let's just follow those steps and see if we fall on the red line, curve, I should say. All right, so normally I start at 0, 0. You're always thinking, what would I normally do if there was no change to the parent function? Well, I'd be at 0, 0. But this says don't start at 0, 0. It says do what? Right 3, up 5. And look at that, I found their starting point. Okay, so I have my starting point, half the battle, right? Now I need to know where to go. So normally, again, I think to myself, normally with a parent function, I would go over 1, up 1. Okay, couple things. I'm not going to go up, right?
No.
I'm going to go down because we flip down. The other thing is I'm not going to go down 1 because this thing stretches. I'm going to go down 4 because it's 1 times my stretch. So 1 times 4 is 4. So go down 4, and there you go. I'm another point on the curve. I'm doing well. Now, I also know that if I go back to my starting point, I normally would go over 4 up 2. Again, we said we're not going up, we're going down. And instead of going down 2, I should go down 8, because 2 times 4 is 8. And there we go. Oops, I missed it. We fall right on the answer key. Always a good sign. Okay, so find your pieces, list them out, find your starting point, do your movements, right? That's the process. This is as hard as it gets, right? Unless you don't, the fractions are a little more difficult. But this is 4 things. Typically, you use like 1 or 2, right? So if you can do 4, you can do 2. All right, the other thing is domain and range, real quick. Here we can see our domain is x is greater than or equal to 3. What does that mean? Well, domain is your possible x values in your function. If we're looking at this green line, well, it begins when x is 3, right? Right here. And it goes forever. So x is greater than or equal to 3. If we think about its range, y is less than or equal to 5, well, it kind of begins when y is 5, right? 5, and then it goes down forever. So y is less than or equal to 5, okay? So that's how you find your domain and range. That's the only other piece. That was the main thing of the homework, is we needed to bring those skills back into play, okay? Now, on the back side of the homework was a little bit of a review of adding, subtracting radicals, multiplying radicals, simplifying radicals, dividing radicals, right? So the back side was a little bit of review. We can definitely go over that as needed. We have a little time, but this wasn't new. This was just like, I don't want to give you 10 graphs. I'm going to give you like 4 or whatever, maybe 6, I can't remember, 6 graphs, and on the back we'll just practice some review stuff, okay? So this wasn't new. That being said, we never got a chance to go over one of those homeworks. So do we want to go over any of these problems? Yeah, which ones?
9 and 10.
All right, 9, 10, 11, 12. You joking? You were joking. All right, well, here's the thing. Anybody need to see 7 or 8? I mean, at this point, I'm not going to go through all the problems. Sorry, we don't have time for that. I will hit every skill, okay? I know which ones are involved in which. So I will choose the ones that you've chosen, and then if it will make the other ones clear, okay? All right, so here we go. Let's go this one. Okay, first of all, you have 5 times a radical times a radical. If you had like 5x times x, right? Well, your answer would be, you think about the number 5 times 1, kind of, and then you'd figure out x times x, right? Same thing here, right? It's not a perfect analogy because x does behave differently than these things. But you have 5 times something and then something. The 5 is going to stay out front, okay? Now, because these are the same root, 3, we can combine them. That's the rule. If they're the same root, we can bring them together under the root. So this becomes the third root of 45 times 3, okay? And then we do that math if we would like, okay? 5 third root of, what is 45 times 3? 135. Okay, now, we have done some great work here, but we are not quite done because we need to see if we can simplify this. And if you sneak a look at that answer, it is more simple than what we have, right? So we always check for simplification. All right, so there's options here. Let's review jailbreak, right? If I have 135 and I start dividing it, what do you think a good number to start with is? 5, right? 5 is definitely going into that. What is 135 divided by 5? 27? Okay. Well, right now, I remember I'm thinking about what I'm doing, right? I'm not just going through like zoning out. I remember I had a cube root, right? And then when 27 pops up, it makes me think, oh, wait a minute. 27's what? It's a perfect cube. So I actually just don't need to keep jailbreaking this. I could make this 3 times 3 times 3, but why? I just found out that this is the third root of 5 times the third root of 27, which is 3 third root of 5, right? So this replaces this, and I end up with 5 times 3 times the third root of 5, or 15 third root of 5. Okay? If you wanted to, you could have continued to break this down, and you would have got 5, 3, 3, 3. Keep 1, 3, get rid of 2. Same process. Okay? All right, next up. By the way, 9, very similar. You do 4 times 5, 3 times 20 underneath, simplify. All right, number 11. Okay, again, I will give you something that I know you can do. If you had 3 times x plus 2, what would you do? Distribute, and you probably wouldn't even write any curves or any math. You'd just go, oh, that's 3x plus 6. I can do that. But what's the math you did in your head, right? You did 3 times x, it's 3x. 3 times 2 is 6. So in this case, because it's a little weird, why not write out that math that's in your head if this is confusing for you, right? Let's go distribute this, and let's write it out. So instead of 3 times x, I have what? Square root of 5 times the square root of 10, and then I would go plus, and then I would have the square root of 5 times 3. Okay, so by not trying to do all that in my head, maybe I'll give myself a better chance of success here. Okay, well, this is like the last problem. If I have a square root and a square root, I can bring it underneath all together and do 5 times 10. What is that? It's square root of 50. 5 times 10 is 50, right? And then this would just be 3 square root of 5. Right? Can't bring those together. That is what it is. 3 times square root of 5. All right, square root of 50. Got to break it down. Now, square roots, we have an advantage. We know them pretty well. So I go, okay, what square root goes into 50? Let me see. 9, 16, 25, 25, right? So this one, we should be able to, I think, break into 25 times 2, right? Plus 3 square root of 5. And then square root of 25 is 5. So it's 5 square root of 2 plus 3 square root of 5. And that's what they had as their answer. Why can't we combine those?
Because they're not the same base.
Yep, same, not the same base, not the same radicand, can't do it. Okay, this one, I will say, the biggest trick here is remembering if you have something squared, it is that times itself. So the first step here is to rewrite this as square root of 5 plus square root of 3 times square root of 5 plus square root of 3, and then FOIL that out, or box.
I did 4. I got confused and I did just the first and the last and not all of it.
You square rooted that and you square rooted that. I mean, you squared that and you squared that?
No, I did the FOIL thing, but it was only the first and the last.
Aha, that is only for conjugate pairs. That's when you have the same term and a plus and a minus, but we have a plus plus. But now you know, and now you won't do it again. Yep, but that's good. It's good that you remembered that. Now we know. All right, moving along. Okay, so this one we would remember our rule that says we can bring things together. So this becomes 5 times big old square root of 20 over 45. That reduces to 5 times big old square root of, both of those divide by 5, right? So I get 4/9. Both of those are square rootable, right?
Yep.
4 and 9. So that's 5 times square root of 4 over square root of 9. 5 times 2 over 3, or 10 thirds. Okay? I know I'm going a little fast. Got to get to the lesson. Okay, last one. This is where you would multiply by that conjugate pair and do the FLA, right? Because you would multiply this by 4 minus square root of 5 and 4 minus square root of 5.
Right.
On the top, you would distribute, you'd get 20 minus 5 square root of 5. On the bottom, this is why we have conjugate pairs, so we don't need FOIL. We can get rid of the OI. We just do FL, F and L, right? So 4 times 4 is 16. 5 times, square root of 5 times negative square root of 5 is minus 5. And that gives us 20 minus 5 square root of 5 over 11. Okay? The middles will, OI will always cancel with conjugate pairs, so don't waste your time. All right, on to the lesson. We gotta move.